Hello, this is Brian Albright, Editorial Director for Digital Engineering Magazine and D247 Online.
And this is Kenneth Wong, resident blogger and senior editor for DE247. Welcome to our debut episode of DE Editors Chat. So the first thing we want to talk about, Brian, I guess, is the return of in-person and on-site trade shows. You are actually going to the first one, and that's TCT plus Rapid. And that show's focus is primarily on 3D printing. How do you feel?
First, I feel very unprepared. As I think I've mentioned to you before, it's been so long since I had to prepare to go to a show that I'd completely forgotten I need to arrange airfare or get a hotel. So it's been difficult to sort of wrap my head around it. It makes sense that TCT Rapid would be a show that goes back to in-person early because it's very difficult to sell these types of printing systems without being able to have the hardware right in front of the end users. And in fact, really sort of the first industry show to go back to in-person was the AMUG conference, the Additive Manufacturing Users Group, that happened down in Florida about a month or so ago and seemed to go off pretty well. Rapid will be in Chicago on September 13th, and I'm going to be curious because this is a much more elaborate show typically than the AMUG conference. It's more of a traditional type of trade show with a big exhibit floor. So I'm curious to see what kind of attendance they have and what sort of differences I'll see on the floor when we're there.
That's a good point, Brian, because the nature of the product makes some trade shows possible to easily convert to a virtual format, and other trade shows like TCT and Rapid, which focuses on the touchy-feely technology, 3D printing, it's really difficult to make it exciting to just aim a webcam at a 3D printer and show you what's happening.
So I expect maybe in the next year or so we'll see a bit of a recalibration about how and when people decide to go to these types of shows and how much virtual content the other shows, maybe not something like Rapid, but conferences that are much more software focused might offer, continue to offer virtual content in addition to having an in-person conference.
SIGGRAPH is this year virtual, and it's from August 9 to 13. SIGGRAPH, on the other hand, because it focuses a lot on graphics technology, 3D ray trace, 3D visuals, and things like that, things that can be easily consumed through a browser window. I don't think that they are going to have too much of a difficulty making a successful show out of that. But
Right.
SIGGRAPH 2022, on the other hand, is set to occur in Vancouver, of course, depending on what's happening with the COVID situation, because the Delta variant that is emerging is worrying news, and it's something that we didn't expect it.
Speaking of virtual events, you also wanted to highlight a story today about a virtual race. Can you tell me some more about that? I know you did some reporting on it.
It's an interesting race that we decided to report on because, unlike any other races, it actually takes place inside a server, as it were. Since it's a virtual race, the cars don't race on a real track, but it races in a virtual environment. This is a race that is hosted by Ansys, and it's called Indy Autonomous Challenge. And this is where, before the real race, well, the real race is going to take place in Indianapolis Motor Speedway track in October of this year. But the virtual race has already happened in June, and the virtual race allows the competing team to sort of test out their self-driving code in that virtual race.
Do they have any sort of anticipation of how closely the virtual race might resemble the actual race?
No, the race may be virtual, but the award money is real. So we're talking about first prize, 100,000, and second runner up, 50,000, not virtual money, real currency. The interesting thing that the winner revealed to me is that, say, in a real race, you watch your rival rival drivers step into the car and you watch the way they race, you understand the personality. You understand the kind of risk that they like to take, how they treat the corners, how they tend to speed up in certain places of the track and things like that. Surprisingly, in a virtual race, you also learn the personality of the team that program the AI car. So you understand whether a certain team plays it safe or not, and whether a certain team has programmed their car to be much more aggressive when going after likely crash scenarios or not. So that's an interesting thing for me. I didn't expect that.
What else did you have for us this week, Kenneth?
I was also going to talk to you about a 3D printed bridge. You reported on it, I believe. And it's a 3D printed bridge that was opened recently in Amsterdam. Have you ever been to Amsterdam, Brian?
I have not been to Amsterdam.
I think I've been there once, but unfortunately, when I was there, the bridge, this 3D printed bridge, wasn't available for me to check out yet, but apparently it recently launched and it involves the MX3D printing firm that they specializes in printing large objects. So we're talking about architectural objects, bridges, of course, in this
Hmm.
case. We have also reported on MX3D printing a robotic arms. What does this suggest to you, Brian, about the direction 3D printing is going with this project?
Well, I think we're seeing definitely in other countries and with other companies that sort of specialize in this large format printing that we're going to see, bigger and literally bigger and bigger applications for 3D printing. We're seeing 3D printed homes. I think the idea of 3D printed infrastructure is certainly interesting, especially in the backdrop of the infrastructure spending discussions we're having here in the US and the fact that those projects here often take a very long time and are much more expensive than they typically are in other parts of the world. If you look at city infrastructure in the US, for example, the costs are really staggering, and the length of time it takes to complete projects is equally staggering. So, if there's a way to take some of these projects and deploy additive to them, I think there's potentially some cost and time savings. And it's an interesting direction for the technology to go. I mean, here at DE, we typically focus on a lot of the part and component and prototype type, production using 3D printing in automotive or in consumer goods. But this sort of architectural or infrastructure printing, I think, has even greater, potential in a lot of ways, provided it can meet the safety requirements needed.
The interesting aspect of this project, of course, is the use of Autodesk generative design software. It tends to show that in the case of 3D printing projects, generative design works quite well, doesn't it? Because in this case, generative design allows them to create the very membrane-like bridge barriers and structures based on the load-bearing scenarios of the bridge. It seems to me like in many cases, 3D printing projects needs generative design for a really good aesthetically pleasing and structurally sound design, and
Hmm.
generative design also need 3D printing to manufacture these kind of design, because without 3D printing, it would be pretty difficult to manufacture these kind of swirly, curving, alien-like shapes.
That's true. And now that you mention it, because we've done some coverage recently of how generative design can be used for other types of production technologies, not just 3D printing. It can be applied, given the right parameters, to machining, injection molding, other types of production processes. I'm wondering if there could be other potential uses for generative design in that sort of, the architecture and construction space that we don't see it normally. Most of the applications we've seen generative targeted at have been, more functional products rather than structures. But I'm curious as to, in terms of the software vendors, how much attention they've given to that for construction.
Let's also talk about some of the important mergers and acquisition news that is happening recently, and one of them has to do with HP and Teradici, and I think you are working on it. What can you tell us about that?
Well, yeah, it's been a very busy year in terms of mergers and acquisitions, pretty much all across all the markets that we cover. This one caught my eye because as a lot of companies are contemplating a return to offices and also different models of working, hybrid, in person, or remote working. Teradici was one of those vendors that emerged as being quite important in that space because they have a technology that enables users to access, HPC and server resources remotely. They've been traditionally a big partner with Dell and some other OEMs in the workstation space, and they have really helped a lot of companies shift into this remote work model that has been difficult in many cases for a lot of engineering use cases because of the type of compute resources they need access to, because of the size of the files they're working with, because of security concerns and IP concerns. So Teradici, emerged as a big player there, and I've most closely associated them with Dell, frankly, just because a lot of the work they've done with that particular OEM. So HP acquiring them just really underlines how important that remote work piece is going to be moving forward, especially for the hardware vendors here. And it sort of leaves me wondering what kind of relationships they're going to have with non-HP workstation vendors. The HP has sort of reassured the market that they'll continue to have those other OEM relationships, but I'm curious how long that could last given the competitive nature of that particular market.
According to HP's press office, so they will retain the Teradici brand. So I think they recognize Teradici has established itself in our space, and it certainly has ongoing relationship with Box and Dell, other OEM vendors. So it would be beneficial to everybody to have this brand stay around and the relationship with other vendors go well. Let's talk about some other things. This is Olympic season. One of my favorite destinations is Japan. Unfortunately, I cannot go there, but there are athletes who are going there, and you have a story that you're working on that concerns the Olympics, I believe.
Yes, we're going to be providing some additional coverage of how engineering has been used in the Tokyo Olympics. Have you been watching the Olympics, Kenneth?
I have watched some of them because I watch some Japanese TV for my Japanese language practice. So I've seen some of the races. It's really funny to watch races with empty stadiums without audience.
It has been interesting. We watched quite a bit. We were watching again last night. I'm based in Cleveland, and a Cleveland area athlete, Katie, I believe it's pronounced Nagioti, won gold in women's pole vault yesterday, or I guess maybe the day before, given the time change. So we've been paying close attention, and I've been more and more curious, especially watching something like pole vault, where as I'm watching it, I'm wondering, is there some physics simulation that will explain to me how any of this is humanly possible? Because I don't understand how you can take a full-grown adult human and move them that far in the air on this very wobbly metal pole. So I've been thinking a lot about it, and I just wanted to sort of close on this piece that I found. It's on the week, but it's based on reporting from the South China Morning Post and some other sources in China that the China Aerospace and Technology Corporation actually helped the Chinese swim team prepare for the Olympics. And they did so using some technology that the government has used to develop ballistic missiles, of all things. They've been creating simulations, and part of that was built on actually having the swimmers sit in a wind tunnel and simulate swimming against the wind. And then they used the data from those tests to calculate drag and help them train better so that they could perform better in an actual Olympic pool.
That's fascinating because we have previously covered the relationship between simulation technology and athletic events before. I remember that we widely covered, for example, the use of Ansys simulation software in um, bicycle races, cycling races, because aerodynamics is very important. Frankly, before I started working at DE, I didn't see the relationship between simulation software and athletic events, sporting events.
And it's fascinating to look at this because last summer we did a whole issue on sports engineering. Uh, and there's all sorts of ways that these types of technologies affect performance. Creating running shoes that have what appear to be pretty significant effect on uh, running performance. And I guess it sort of moves you into this ethical question of, you know, how much are we in balancing a race using certain types of technology? If we're designing better shoes, how much of this is the runner, how much of it is the shoe, or whatever piece of equipment they may be using, like a javelin or the pole for the pole vault. Or I was also reading that the just design of the Olympic swimming pool has been altered over the years to help improve the speeds of the swimmers. So for instance, if you took a gold medal swimmer from this year's Olympics and put them in a different type of pool, you might get different times from them, just because of the way the structure is designed.
That's right, because this is an interesting debate that is ongoing, I believe. When you are able to use technologies to give your athletes certain advantages, at what point do you cross the line? Formula One, for example, I learned while I was writing this story about the Indy autonomous car race that Formula One, for example, bans certain self-navigating um, vehicle-related technologies. Control trans automatic control transmission is one of those technologies that was banned since 2007 in
Mhm.
Formula One. And the organizers' argument is precisely what you pointed out, that they want to see the skill of the driver, not necessarily the technologies competing. On the other hand, of course, the race like the Indy autonomous race is specifically designed to highlight the technology and what you can do with the technology. It's an ongoing debate, and I don't think there's an easy way to settle it.
Probably not, but I'm going to be continuing as we wrap up the Olympics this week, watching for areas where I think maybe uh, simulation may have played a role in producing some of the really phenomenal results we're seeing out of the athletes.
That is all for this debut episode of DE Editors Chat. Thank you very much for joining me, Brian. I really enjoyed our chat, and I hope we can continue producing this series.
All right, thank you, Kenneth. Me too.